Hi, my name is Oliver, and I'm a Senior Delivery Principal from Slalom, San Francisco. Today, I'm going to cover an architecture that I use to solve a text classification problem using AWS AI services as well as SageMaker. This exercise is part of the Machine Learning Black Belt program in fall 2020. So let me start off with the business problem. Building and producing products that are actually adopted by customers and solve real problems for them is a historically challenging task. Today, imagine that you have joined the machine learning team on Amazon e-commerce site. Your web page is full of reviews from customers for each of your products. Your product owners want to know about a negative review immediately. Ideally, they like to know why the review was negative. The Amazon reviews data that was provided in our scenario contains about 3.6 million reviews. It contains the review text and summary, and the reviews were already labeled as positive or negative. There were two phases for this text classification or topic modeling project. The first phase used an AWS Comprehend analysis job to generate the topics. The second phase was to build my own topic modeler using SageMaker, which I picked the Latent Dirichlet Allocation, or LDA, algorithm to solve. So the overall architecture for both of the approaches is here. But let me first focus on the AWS AI services approach before jumping over to the custom architecture. Let's dive in. So for Comprehend, there are a number of built-in analysis types. There are multiple ways to create an analysis job, including direct creation in the AWS console, or via the command line, or using the AWS SDK. In the deep dive section, I'll be covering the details of creating the job from the API. So, I have downloaded the Amazon reviews data and extracted it into a S3 folder. From there, I created a Comprehend analysis job using the topic modeling detection type. The output of the analysis is not a model, but a number of topics that Comprehend is able to identify from the data. And from there are multiple ways to parse the output. For topic modeling, it's as simple as reading through a CSV file, since the output is in CSV format. But the reason why I have a crawler and Athena set up in this path right here is that Comprehend analysis job does sentiment analysis and other detections as well. And for those particular output formats, it actually is easier to let AWS Glue crawler to parse the output, and then you can use Athena or maybe even QuickSight to query as well as visualize the data. During this project, I did use Comprehend to run through the sentiment analysis through the Amazon reviews data, and I'll be covering the details during the deep dive section later in this video. So stepping back a little bit, I do want to focus on the Comprehend topic modeling output in this overview. Since it was a quick analysis testing out the AWS AI services capabilities, I decided to use a smaller subset consisting of 100,000 negative reviews and see what Comprehend would come back with. The topic detection analysis took less than 30 minutes, and note that there was absolutely no pre-processing involved, and you can specify the number of the topics to generate. As you can see here, I specify the number of the topics to be 20. You simply feed it with a data file and Comprehend would magically come back with a list of topics, like the table displayed here on the right hand side. The problem though is that these are more individual terms, not phrases, although in most cases the first term would carry the most significant weight. When you combine the first few heavier weight, let's say this one here is a storybook, and I don't know why, for some reason it's running on the negative reviews, but it has the word good in the review text, but it could be a good movie with a bad song, right? What's being formed is more of a single term category rather than a proper topic in in phrases, and it makes it really hard to judge what the actual reasoning is for the negative reviews. With that, let's jump to the second approach, which is a lot more involved, especially in data preprocessing. This custom architecture includes a designated data repository that is treated as a data lake. Although I do not have multiple data engineers or roles created in this project, the power of data lake formation in configuring the data lake really allows personalized access for various roles or users. And the CRUD permission or access can be very fine-grained. Since we have a source CSV identified already, we do not need to leverage the blueprint capability to ingest data from the other data sources. But this could be helpful for future solutions, especially when a real-time data analysis requirement, let's say for production data, is introduced. Once we have the data lake set up, the crawlers, the glue jobs come in super handy to analyze, visualize, and process the data. I'll be walking through the multiple crawlers and multiple glue jobs as well as the QuickSight dashboard in much greater detail in the technical deep dive. But to give a quick overview, the end-to-end process is as follows. So the CSV is put into the data lake in a particular location in S3. Then the glue crawler parses the CSV data and registers a new table in the data catalog. Then the data scientist can start the data analysis by querying the S3 data using Athena. QuickSight visualization dashboard can also be generated. And once certain insights are being drawn from the data, we can start using glue jobs to clean up and process the data. And that processed data is written back into S3. Now notice that multiple glue jobs can be chained together. You may have a job just to extract the negative reviews, another job to remove special characters from the reviews, or even remove non-English language if necessary. That's why there is a cyclic action, number 8 here, happening until you have all of the data completely processed in the bucket and then is ready for training. Once we have the ready data in the bucket, then we can use SageMaker to run the model training using the LDA algorithm to give us a list of the topics, which is right here. Now let's take a look at the steps of data cleansing. These are some of the techniques that I have applied to the data before the topic modeling training. First, I filtered the reviews to negative reviews, and then I combined the title and the review text into a single column. Then the standard procedures such as removing special characters, lowercase everything, removing non-ASCII characters, and so on were also applied. I also removed an English stopwords using the Python natural language toolkit before eventually tokenizing and lemmatizing all of the reviews. Now here on the right hand side, I have an example of one of the shorter reviews found in the data. The title of that review was ugly, and the text was, "This ring is so ugly and huge, but it's okay for your daughter on Halloween or something. If she is going to be a princess or something, I wouldn't wear it in public." To note that everything is already lowercase, all the punctuation is removed. And then I applied the step of removing all the stopwords. Now in the natural language toolkit, stopwords include words like this, is, and, if, in, and so on. These are really common terms that doesn't necessarily give like much meaning to the sentence. And so after removing the stopwords, you would get the sentence right here. Ugly ring, ugly huge, okay daughter, Halloween something, going princess, something wouldn't wear public. And eventually I would tokenize this into basically individual words, and finally lemmatizing the sentence. Now, lemmatization is basically to return a word back to its base dictionary form. Example here would be, from going, after lemmatization, it becomes the word go. So after the data processing, and of course, this is applied to all of the reviews, close to 1.8 million negative reviews. And once we have the processing done, we can go into model training. Now I have ran multiple training jobs during this project, but I wanted to use these two examples here to show some contrast. The top piece here basically took the negative reviews almost as is, just lowercase and removed all the punctuations and fit it into the LDA algorithm. As you can see, I have exactly 1.8 million reviews, and from that I use 80% of that as a training set, which brings to the size of 208 megabytes. And the vocabulary list extracted out of that training set was a little over 90,000 vocabularies. Using the instance size of the C4 to X large instance, the training took about close to 30 minutes as specified right here, and the cost is around, well, it's a little over a quarter. Moving on to the bottom one right here, as you can see, I have processed, tokenized, lemmatized, stop words removed, as well as non-ASCII characters removed during the process. So I found that, there's actually a couple thousands of the reviews were written in Spanish. And so it brings down to this number. And because of the stop words removal and good things like that, the training set size got reduced from the 208 megabyte, as you see at the top, to only 170 megabytes. And also the vocabulary list was substantially reduced by close to 40%, bringing it down to about 54,000 vocabularies. Using the spot instance training, which you can specify during the job creation for model training, I was able to get a cost saving of 58%. And this training job right here took a little over I think 20 minutes or so, and it only spent 8 cents for the training. Well, let's take a look at the result. I have 25 topics generated using the LDA algorithm, and it's not surprising that we have the same problem as what we have seen earlier in the Comprehend results, that we have a good list of the terms forming a topic, but they're not phrases we're looking for. And it doesn't give us a good reason why the reviews are bad. But the result was also very surprising to me that it is very similar to Comprehend. Now, let me bring up the Comprehend results I showed earlier for comparison. On the right hand side, this is the results coming from Comprehend. At a high level, you should be able to tell that both lists give almost the same terms. Now, let me highlight just a few to show how similar they are. Example would be maybe number 19 here, quality poor sound. It's very similar to the Comprehend result of this one. The first couple of the heavier weight terms are exactly the same. Another example would be, let's see, number 20, make coffee. There's also the term of like water. And if you look at on the right hand side, number 2, make coffee, water. So again, all the results are very similar. This is very exciting. It tells me that the algorithm and the cleansing procedure that I have used comes in really close to what Comprehend is offering. It tells me that I am on the right track and I can tweak this a lot further. Unfortunately, I did not get the chance to enhance the entire solution before the Capstone project comes to an end. And so I have captured a few recommendations for the path to production design. Let's go over that really quickly. So from this Capstone project, I learned that the terms returned by Comprehend topic detection analysis, as well as the Latent Dirichlet Allocation, the LDA algorithm, are not in the topic phrases format that I was looking for. But the terms are actually great for classifying the reviews. The categorization should be applied to all of the reviews. We saw that the categories like music, book, movies, and so on. And I would recommend to get more features if possible. Although the data is coming from Fast.ai website right now, and it's coming in a compressed CSV format. In production setting, I would imagine that the date of the review can also be provided. The date information will be very helpful in identifying the negative reviews reasonings because there are seasonality and trends for product reviews. For example, a movie that was released in, let's say, DVD format many years ago probably got remastered to a higher definition in Blu-ray format, and that probably would give a very contrasting review. Once we have categorized the reviews, and if we have that date information, product owners can then start questioning things like, what are the reasons for negative reviews in the book categories for the past 6 months? However, and this will require many iterations of the topic modeling training, you probably need a set of trainings for each of the categories. For example, you want topic modeling for book reviews for the last month, for last year, or maybe for the last 5 years. You also want topic modeling for movie reviews for last year, or maybe even just the last week. And more data cleansing will be required. When you have categories in its own feature column, you'll probably want to remove the category information from the review text column itself. So iterations of topic modeling training can really start showing the reasons behind the reviews. In production setting, latest review data can also be ingested into the pipeline by many different means. It can be lake formation blueprint to ingest the data from a database. It can be data migration services to copy the data into S3, then apply the constant crawling of the S3 data using the glue crawler. Again, there are many different ways to tackle this, and this will give close to real-time analysis of the review. For additional features in the data, ground truth can also be leveraged to provide that extra context to the reviews data, and this can totally be powered by the Amazon Mechanical Turk workforce. And finally, there's also the hyperparameter tuning that should be done, and probably many times to get to very high accuracies of the model. All right. This has been an amazing project. The hands-on implementation, especially in standing up the data lake, creating specific crawlers and glue jobs for this Amazon reviews use case is totally applicable to so many different other real-world scenarios. I really appreciate this wonderful opportunity to participate in this Black Belt Capstone project, and thank you for watching this overview.